Let's go to Module 7. From Module 7 to Module 9, we will spend 3 modules to introduce statistic application to data science. In the first part, we will first introduction to the statistic. Then we will introduce graphic summary and the numeric statistic. So the first thing, let's talk about the statistic. Basically, we can say statistic is the study of learning from data. So that's why it's so important for data science, because we are applying the data to try to find out the information from data. So definitely we need to use a lot of statistic concept. The content make the data informative to facilitate good decision. So after we get the data, we collect the data, we analyze the data with the statistic value. Then we will see how to interpretation and how to interpret the data. So after we went through the 3-step data collection, analysis, and interpretation. So it is the objective, creditable, and defensible quantification of a research study by taking an unbiased random sample from the population. So whenever we have the data, you need to understand all the data we get actually is for the real life. So the real life, we have specific population. But sometimes your population, your target is so big, so we maybe just can get some of the sample from the population. So that's what we call the sample should be random. And the most important thing is should be unbiased. So that's the important thing about our data. After we can get unbiased random sample from the population, then we can apply the inferential technique such as estimation, hypothesis testing, and the prediction. Then we can generalize the result of a research study with a level of confidence to the population. So that's why we call statistics is the science of uncertainty. We just don't know what happened on the data. So that's why we need to analyze that. Then hopefully we can predict that. Statistics is also a probabilistic evaluation of the events, as opposite to the deterministic evaluation, where the conclusions are predetermined. So statistics actually sometimes based on the probability. So that's why we not really know what will be happen. So we just can try to interpret the data. So that's not really we can determine anything yet. But sometime right after we evaluate the data, hopefully we put into the model. So then we can have the model, then we can do the prediction. But statistics basically is not doing the modeling yet. So that's why statistic analysis is by mathematical intuition of probability helps differentiate significant variance from the chance variation. So it depends on your sample, how the sample came from. We may have the sample-to-sample variation. So then we were using quantitative measurement. So those quantitative measurement, you can say that will be the variable can be represented by number. So then we're using the mean, model, or variation to represent the data. So statistics usually can answer the question like, we can compare two depression related to the specific medicine. We can check in a client regarding to the surgery or the new Medicare medical procedure. So we can comparing and contrasting intervention to cure arthritis by clinic trial. So that's why we can using those data, the sample data from the population, and using applied statistics to answer the question. So that's why after we apply the statistic, we have the statistical analysis process. The statistic analysis process including the first one, you need to decide the research study objective. You will summarize the data. You analyze the data. interpret and provide the conclusion. So of course, after you have your study objective, then we will see how to find the population to get the sample. So we summarize data, analyze data, and interpret and provide the conclusion. Basically, we have three different branches of the statistic. We have descriptive, we have probability model, we have statistical inference. Descriptive branch actually we see a lot. This branch is a study and summarize the data using the central tendency measurement like mean, median, and the mode, because that came from the numeric number, so we can calculate the mean, median, and the mode. Then as well as the visual representative, we can represent the data using the histogram, pie chart, box plot, or the line chart. So those can help us with using the data to do the visualize the data. So this branch also describes the variability of the data by measuring like the standard deviation, the range, and interquartile range. The shape of data is also addressed by this branch. So that's why the data visualization is important. Then also we have the probability model. So this branch of study that deals with computing the probability of obtaining a particular sample outcome. Once we compute the probability of various samples, we can then generate a probability distribution. The probability distribution actually we have two kinds. They can be discrete, that's a binomial, or be continuous. So usually we see that's the normal distribution. This probability distribution can be used to model real-life situation. So statistic can use this sample probability distribution model to help make inference about the population. So afterward, the last branch is the statistic inference. This branch of study employs the sampling probability distribution and the various descriptive measurements. We can implement various inferential techniques and they help to reach conclusion, generalization about the population. The inferential and association technique, including the hypothesis testing, confidence level estimate, and correlation as well as regression. Even we have three different branches about the statistic, but the most important thing is about data. So that's why the next one, let's go over the keyword earlier we told you. What is population? What does mean the sample? So population actually is the universal for a class of individual. They can be an event of object. It includes the whole collection of individual events and the object in the study. So that's our subject. So for example, the population can be all the colon cancer or the depression patient in the world. So remember, your population actually means everything related to the subject, every sample related to the subject. So the parameter, you have numeric value that summarize the characteristic of the population. You have the mean of the blood pressure of all the colon cancer patients that's in the population. You have census, collection of the data from all the individuals for the population. But sometimes we do have the population, but if we want to do some research or do some analysis, then we can interpret that maybe we don't need to have the whole population. Maybe even we are focused on the high blood pressure of all the colon cancer patients in the world. But maybe we don't need to take all the information. Instead, we have the sample. So the sample actually from the population is the smaller group. You can say that's a subset. The smaller group of individuals entitled from an amalgam from the population. So they are part of the population. It is used when it's not possible or practical to test the entire population. So then we just got the sample. The most important thing, sample should be representative to the population. So the sample example, we can say we only get the 10,000 patients with a clone cancer randomly chosen by the population. So the same thing, we can still using the statistic to represent the sample data. We have numeric value that summarize the characteristic to the sample. For example, we have the mean of the blood pressure of the sample for the colon cancer depression patient from that 10,000 patients from the population. So after you understand the sample and the population, so then we have the reason for the statistic analysis. So when you do the research question, so you will have estimate the population parameter. You want to know the percentage of the people who favor a candidate of the presidential role. So then you will test a claim about a population parameter. For example, you will do more than 50% of the doctor approve of the new procedure. And sometimes your research question also can be, you try to compare two population parameters. So, for example, if the mean of GPA of students before and after an online training class will be the same. And also you have the relationship between the two variables. For example, is the mean of the GPA associated with the IQ of the individual or not? So those things are all the reason for the statistic analysis. We have some research question we want to answer. Right, we say we have the population, we want to get the sample data, right? But the sample data is what kind of data? So the difference is versus the relationship. Statistic question can be categorized into two groups, namely differences and the relationships. For example, a statistician will be able to ascertain the difference between the blood sugar level of diabetes versus the non-diabetic person. So that's why we need to get the blood sugar value from the diabetic patient and from the non-diabetic person. On the other hand, we might like to ascertain if there is a relationship between the blood sugar level and the blood pressure. So that's why you can see whenever we try to develop the statistic research question, we focus on the differences and the relationship. Is any blood sugar level will be different from two different type of person? Will the blood pressure have relationship with the blood sugar? After we know the target, those variable is what data we need to collect. So when we try to collect the data, actually we have the characteristic of those measurement scale. So those measurement scale can be a nominal, can be ordinal, can be interval, can be a ratio. So those kind of category, the type of variable, you can see the nominal can be the categoric variable. So ordinal also is categoric data. So we can identify the group. We can identify the rank. For the ordinal, we can do that. We can identify the magnitude of the ranking. But for the nominal and ordinal, we cannot do that. But we can do for the interval and the ratio. So then you also will ask that, do they have an absolute zero identified magnitude of the ratio? Can we calculate the mean, the median, and the mode? So that's why according to your different measure scale, then sometimes those data variable can be categoric, can be quantitative, can be continuous.